Alrighty, we're live for day 16 of Advent Code 2024. And, one sec. And yeah, we have about 15 minutes left for that. So, for warm up, I've been going over past year problems for warm up, and it's occurred to me I could be going over the past year problems that are referenced in all of these. So, each of these problems, I don't know, let's say day 2024, day 3. This references 2020, 2020, day 2, which I think I've already solved. Yeah. So I want to start going back through and solving all of these reference puzzles, and I put them up here. Since we only have about 10 minutes, I'm going to pick out an easy one. Hey, Blue, how are you? Feeling better? How far along are you? I'm realizing that I should be solving. Well, I have been solving past year problems, but I should be solving the past year problems that are referenced. So 2024 day 2 references 2015 day 19. That's a day 19 puzzle. Maybe I'll skip that for now, but I'll leave a tab open for it. Day 3 references 2020 day 2, which I have solved. Okay, so we'll skip along. Day 4 references 2019 day 10, which I don't think I've solved. I have gone back through 2019, but just the int code. Do you want to do a day 10? Let's think about it. Let's give it a read. Um, oh, and the other thing I'm realizing about this map, so I mean, it's a 10, right? Because it's the 10th year. But what's in the map is references to past year maps. So I want to try and figure out which is which year. Maybe that's what I'll do for warm up. Is just dig into this. Hey, Hellhound, how's it going? Day 14. It is tricky. It's fun though. So you're doing part 2 then, I take it. Arrow Bounce, welcome, welcome. So you can anxious for today. Why is that? I've had some rough day 16s before. I think day 16 a couple years ago was the elephants and the pipes. That one, that one I struggled with for a while. There's a lot of debugging that night. So I'm going through the calendar and trying to understand it a bit more, right? Each day references a past problem. I'm going to go back through and solve all of those. But I want to figure out what's going on in this calendar. It can't be worse than yesterday's part 2. I mean, yesterday's part 2 wasn't terrible. You might be talking about day 14's part 2. That one was a tougher one. Okay, so 2015 was a Christmas tree. I think that's this one right here. Um, I wish I had a record of how the calendar changes on each day. Michael BC Gamer, hey, how are you? 2016 is a city. I don't think that's on the map yet. Soggy boy, how are you feeling after last night? That was a late one, huh? What time zone is everyone here, by the way? Anyone else doing this right at midnight? 2017, what is that? Oh, that's a circuit. That's a circuit board. I don't think 2017 is on our map yet. 2018 is that. Oh, wait, that's gonna have more. It's not showing much because I haven't solved much of 2018. Mm. So I'm not sure if it's there. 2 a.m. over there. Jeez, you're like in the Atlantic Ocean. Right, right. It must be like 7 p.m. for you, Soggy Boys, 6 p.m. Pacific time. That'd be great. The very first year I did it, 2021, I was in Pacific time, and that was much nicer. Um, 2019 is a solar system, which I don't think that's there either. 2020 is right. You're taking. I'm not sure what that is. I can't remember the theme. I've done most of it. GMT -3 for Hellhound. How do you? Where is GMT minus? That's like right in the middle of the Atlantic Ocean. Oh man. Oh, you must be. Are you like Iceland or something? Greenland? And 6 a.m. for Zara. Must be Germany. Okay, so these are the years I've completed. 2021. Oh, right. This was the Under the Ocean. Um, is that this? I'm not sure. No, this is water here. Maybe. Is anyone here about to be in the 500 star club by the end of this year? Cologne, Germany, and Brazil. Okay. Oh, that makes sense. But so you must have a daylight saving time in the opposite direction too, in the southern hemisphere. That explained the time. Arrow bounce. Okay. So you're recognizing all these references and whatnot. 2022, right? The jungle with the monkeys and the elephants and the lava. Um, is that this in the left corner? Top left? I'm not sure. Juan Copperu, thank you for the follow. You currently have 476 stars, so you're missing 4 from past years. Ooh, I'm curious which ones those are. They must be good ones, good challenges if you decide to skip over them. 2023? I don't even remember what was the theme last year? Um, Let me read the first problem. Trebuchet, right? The elves were just running around the island, doing crazy shit. Hmm, what else happened? Launch into the atmosphere, right? Trip. Yeah, I guess just gondola lift, traveling around the island in various ways. Yeah, different islands, that's right. You had a conference during the weekend. Lost time and points. Uh, yeah, some of them are a bit fuzzy for you. That makes sense. This would have been the year to go through all of them. That'll have to be in this upcoming year. I do want to get all 500 before 2025 drops. Because the real 10th anniversary is day 1 of 2026, right? Even though that's the 11th year. because that will have, right? Day one will have been 10 years since the first one was released. Hackers to Hackers Conference. Ooh, sounds fun. Right, fixing snow production on the islands in the sky. So I wonder what the day 25 problem will be. Like, will it be a meta, like a meta puzzle of some sort? Will it have a bunch of references to like all past years? You need to have stars from previous years for day 25 this year. It's a Brazilian DEF CON. Sounds fun. Do you plan to go to, have you been to DEF CON? Do you plan to go sometime? It wouldn't make sense for me to go, but I would like to be like a fly on the wall. I've watched a few DEF CON talks, and they can be pretty fun. Hmm. Yeah, I want to have all these maps lit up. I did really like this under ocean theme. My favorite year so far is still 2019, just because of the Encode series. That was a lot of. I don't think I finished the Encode series actually. Yeah, I have 1 star in 17. I'm not done. But I'll. Oh, yes, 2-minute warning. I'll get to 2019 sometime. I think I'll make it real nice. I want a real nice Encode implementation. All right. Good luck, everyone. I'm gonna save this set of windows for later. And what to do? Do I already have a day 16 up? Yeah. Sit here and chill. Fair enough. Good luck, Soggy Boy. If I finish first, maybe I'll come visit. Hmm. Good luck, Arrow. Get some points again. All right, 10 seconds. Okay, reindeer maze, reindeer meters. Hey, we might have our first extra. I mean, don't necessarily have to do that, but yeah. Okay. So what's the catch here? This is the big event. Rangers compete for the lowest score. Start and they can move forward 1 tile at a time. Okay, what's the catch? Never into a wall. They can rotate. Rotating increases your score by 1,000 points. Okay, how about moving? But taking any of the best paths would incur score. Um, okay, 1 point to move forward, 1,000 points. So there's a cost to rotate. So our states must include the rotation. Um, yeah, let's parse this. So val maze to vector. Import AOC dot point area direction. Haha, it knows what I want from maze. That's so great. Okay. Let's see. Well, the start position, and what we want is actually the S, val, and pause. Okay, and then walls knows me. Okay, and a Dijkstra. So we have a depth search. Um, we have a start state. We can just define that in here. We have a next that goes from state to state. Case class state, not steps. We want points. And we have a position and we have direction. Okay, and then we have def next. So we get another state. And I don't want that. How do I cancel Copilot autocomplete? Okay. We want the adjacent stuff. Well, let's see. Where can you go from here? You can rotate or move forward, right? So I guess we just do a list of 3. We don't even look at adjacent points anymore. Oh, hold on. The 3 that you can turn towards, we'll just walk into the next step and then calculate the score for walking to there. And if it includes a turn, then yeah. So let's do point or position dot adjacent. And then we do some filters. So dot filter in bounds of our area. And then we're gonna div walls. What else? I guess there's the visit, but we can do that down in the actual Dijkstra implementation. What's the problem here? Yeah, that's probably not arch. So next returns a state, and we have equals. There we go. So make sure we're in bounds. Make sure we're not hitting a wall. And then we map. Well, each of those adjacents comes from the direction, though, doesn't it? We can't just do adjacents. So instead of pos.adjacents, we're going to make our own set. So set of, we're never really going to go backwards. We'll just plug in the direction dot left and direction dot right, along with the points. No, we're going to take our current position, pos dot move in the direction, and then add 1 point there, and pos dot move in the direction dot turn left, and that gets 1001. Okay. And then pause that move in the direction turn right. 1001. Okay. Um, I'm not sure if I like it this way. Let's just make this. Let's make this a list. No, no, no. We're just gonna have two filters here. Yeah. So list.filter. So next is gonna be a list of states. So we filter that the point is not in walls, and we filter that the point is in bounds. And then we map the position and then the score, I guess, to P. Oh, we should be holding on to the directions. Crap. We want the direction in this. You got it already? Ah. Okay, so dir dot turn left, dir dot turn right. Okay, we can zip that with the points later. Okay, and we're gonna map each direction. We could keep the direction and do pause that move in that direction and direction as well. There we go. Yeah, so now we have a position and a direction. Okay, so we make sure that position is there. Now we zip with list of 1001, and 1001. Great map. Um, this is a position, direction. We've got a case here. And then we have the score, points plus S. So P, D, points plus S. Um, yeah, let's do it that way. Oh, and we've got a weird syntax error here. All right. State goes with positor and points. What's the issue here? It doesn't know what P is. So once we do the filter, we still end up with a list of point and direction. And once we zip it with this list, we should end up with point, direction, and score. So what's the issue? Okay, weird syntax error. So we can have some sort of winning state here. Yeah, I haven't reviewed any Dijkstra. I've kept thinking to myself this year, oh, I should review Dijkstra and just have it ready to go. Import collection dot mutable dot the priority queue, and I think we'll want a mutable map as well. Um, okay, so we have a start. It's going to be start, pause, direction. I don't know what our start direction is necessarily. Is it going to be north? Facing east. Okay. Facing east with 0 points. And then we'll do a visit set. Okay. And how do I usually use my map? So we have our okay, we have our queue. Um yeah, I guess we keep the points in there. I don't think we want the points in the state. I think we just want the delta cost. Okay. Um so something like that. So how do I usually like to do this? Um we have our next. So current. Let's have a visiting. Yeah, the way I have it set up here, we'll be allowed to revisit a point if a position. So this shouldn't be part of my visit state. What if I just I'm just gonna change my visits to have point and direction. Right, so the location. And it doesn't need to be empty. You can just start dot pause and start dot dir. Okay. Cool, cool, cool. And I guess we want enable set. Okay, so we take our current, so visiting dot next. Um, and then for each of those, yeah. So we'll do S for state. Um, no, I don't like that. Um, I don't think Q non empty. That's ridiculous. But we should do while visiting is not equal to end. Then we keep moving things around. So we add these to the queue. Q dot NQ. Oh my god. NQ. And what else should we do with it? I don't think we need to do much else right now, do we? And then visit or visiting equals q dot eq. And then we just return visiting because it's at the end position. So we search starting with, well, I guess with dot next. Search. Oh, and visiting is going to be start. while visiting that pause is not equal to end pause. Okay. Our next should be state to a list of state. Okay, great. Now we still have, this looks like a syntax error there. We're missing that zip. And we have too many parens. No. Yeah, okay, there we go. So this should be running now, right? It should be running faster. So I messed up somewhere. Yeah, so I confuse myself because sometimes I do this with a map from the states, which would be the position and direction, to the score for that position. Um, and then I use that map in my ordering for the priority queue. But this time around, I've done it a little bit differently. And I included everything in my state. Probably because, yeah, it depends on direction we turn. Okay, so we failed here. Let's take a look at why. I'm just going to cancel that. Um, so we had the start state, and we keep checking if it's at the end position yet, right? Um, priority queue, it's ordering by negative points. I can also reverse. So we can order it by the points. Oh, hold on. No, I was just about to add a heuristic. This is the place where we would do like add a heuristic, turn it into A star. Um, but that's not necessary. We just use, let's, let me double check the order of the priority queue. Scala API priority queue. Okay, does this do the highest first or the lowest first? I can't remember. Um, okay, DQ all. It goes the highest first. Great, and we should be start searching from the lowest first, right? So you pop the lowest off of the queue, and then we continue searching from there. So using that for each we in queue. Do I have enough filters in place? I placed all the filters here basically. We make sure that we're not hitting a wall. We make sure that we're in bounds. Um, is there anything else visited? Wait, I never used visited. Oh, okay. Unused local definition. There it is, right there. There's my problem. Okay, so visiting next dot filter or filter not visited. There we go. So that should run. It's taking a little bit longer than I want it to. This isn't that big of a map. Yeah. Oh, okay. We got a different problem. So day 16, we found, oh, right, which is a compilation error. So filter not found a map acquired. Yes. So given our state, visit state dot pause and state dot direction. Okay, okay. Let's just put these in like separate lines. So for each, we could just write this way. Q dot and Q. Okay, that should work. That should work. Right. Oh, we have found unit, found seek state to unit. Hmm. Well, I just want in Q1 for each S. Why is it taking so long to tell me there's a compilation error? That's weird. Hmm. Okay, so and Q takes variadic arguments. So I could actually just pass that whole thing here. Okay, we hit a timeout. Um, so we're still not filtering enough. So we filter not. So you make sure it's not something we've already visited, right? So that's good. We're not going to go in any infinite loops. And let's see. When we compute the next states, that this seems sane, right? Make sure we're not hitting walls. Make sure we're still in bounds. Um, we're looking ahead, left or right. Um, where is it? Eesh. Okay, let's just check if it's doing the same thing on the example input. So day 16. I suspect that it will have the same issue because this seems like I've misprogrammed myself into an infinite loop. So we'll save this as dash example. And if this doesn't work, we'll do some sort of print debugging. Okay, go to the example. And while that's running, let's start thinking about how we want to print. Let's just print what we're visiting to start. And now I suppose um, we gotta run this in the console. Okay, so let's print this. This is my, oh, is that right? All right, so we can see where we're searching. So 115 and 114 north makes sense. It's prioritizing north. At um, some point it has to up it, right? Wait, how's it still facing north in all of these? How do we have an east with 15? Okay, we start with an east with 0. Um, how are we having a north with 1 point? Let me see how I'm doing my zip here. I might be misprioritizing something. So this, um, the same direction, turning left and turning right, is zipped with 1001, one. Um, oh, hold up, hold up. This zip happens after the filter. We can't have that happening. Okay, so here we can map the direction. And I guess now we have to do this. So, no, no, no. Let's do it this way. We have the direction and we have the score. So let's get the position, direction, and then the score. Make that a triple. Position, direction, and then the score. Okay, so in the filter, we have a position. Now we have a direction, a score, direction, a score. We take out these parens here. Okay, let's rerun that. Nice, both parts. Okay, this should look better. Mm. So east, and it goes directly to north because that's the only option, right? That's right. We start facing east, we go directly to north. Yada yada yada. Great, 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 great. Um, cool. And we have an answer. 1104, 8 points. 11048. Okay, great. Let's run that on our real thing. Take out the print line and get our part one. Um, 20 seconds seems like that's too long. This should be faster than that. I could add in. I could add in a heuristic, but I don't feel like that should be necessary, especially for part one, right? Okay, so the directions, we zip the scores, we add the positions where those directions would lead. Then we check on those positions that they, I guess we could merge these two. That the position is not a wall and we're still in bounds. Fail to evaluate. Okay, so this isn't running fast enough. Let's look back at this and make sure this approach is making sense here. Um, this is looking good to me. So at some point, let's just do the left side of the screen so we can look at this. So here's the path that we would be following, right? And for the longest time, there are no alternative paths until we hit here. I don't know where that is. Oh, wait. Uh, no, no, even though my north and south is flipped, so it would be flipped. If I were to print this, it'd print it upside down, but it's flipped at the parsing and at the interpretation, so that's fine. Uh, yeah, so it keeps on going north until we have 0.11, so all the way to this corner. And then now, the next thing it chooses to check is this east down at 5. Okay, that looks good. That looks good. Um, okay, well, surely I don't need more optimization than that. Let's see what this looks like in the REPL. I want to see why that's taking so long, or what happens at the point that it stops. Maybe the actual input has an issue. Maybe it has a loop that I'm not catching in here. Well, this thing has loops too. I don't know. Okay. I don't seem to be able to paste or do anything for that matter. Let's start a new REPL. Oh, no, no. Huh. Okay, we're just going to restart SBT. I don't know why it's lagging out on me. Do I need to kill all Java? What did I do? All right. So this times out after 30 seconds. I mean, should I just make it run longer than 30 seconds? Maybe I need to allow it to run longer than 30 seconds. Oh, hold up. We're not the console yet. Okay, here we go. Oh, I see what's happening. Okay, there. This is a list of things from which we are searching. And yeesh. I should be what I should be doing. I should condense this. I'm going individually state by state. And I should just be looking all the way ahead to the next point. To the next intersection rather. Okay, I mean, we probably need to condense this for part 2 anyway for performance, so I'm just going to do that right now. We're going to condense our search space to nodes representing the intersections. Your computer crashed halfway through part 2. Your computer crashed due to memory issues. Let's see with the JVM you can allot it an amount of memory. Okay, so too many states in here. We're going to do fewer states. So instead of this 1, let's set a helper method. So def next intersection. Yeah, and an intersection will be anything that has a has what? Anything that has like an adjacent that's empty. So we iterate, continue moving that direction. Yes, and we drop 1. Great. Why is it drop while walls? I don't want that. So drop while neither, so given this position, neither the left or the right. So val left. No. You just want dirt up and left. So, well, neither the left or the right, p dot move, or well, both are walls. So we'll say it that way. Um, def blocked. So we'll say blocked if, yeah, walls contains that point. Drop as long as both are blocked. P dot move left and is blocked. And actually, we could just say walls. Walls and walls p dot move right. Okay. You needed some HQ magic to address part 2. HQ. Okay. Um, I'll ignore that. I'll not think about it too hard. Might be a spoiler. But I do still have a star in my back pocket. I could do there are two things I could do for optimization, right? So I could do an A star with a heuristic, and I can condense condense the search state a bit. And that's what I'm doing here by finding the next intersection. So we drop while there are walls to the left and right, and then we take the next. And that is our next intersection. Should I do next option? Yeah, there might not be a next intersection in that direction. Mm. Okay, but at that point, we also want to know how far away we are. So just, we'll make this dot next. Dot next. We're not gonna deal with options there. Um, we also want the score there, right? So int. Um, so we're gonna zip this with index and drop while the precision. Ignore the index for now. And yeah, that tells us how far away it is. Okay. So now we do what val next intersection. So we call it. So we'll call it. I don't know. Let's call it inter and distance. Cool. Now here we do inter.move into that potential next spot, and we add points plus dist plus s. So that should significantly reduce our search space. Let's get that shot. And while it's running, which already seems like it's running too, what other ways can we optimize? Yeah, okay, that timed out at 30 seconds, but let's take a look at it. I want to see all the output before it crashes. Hmm. Oh, I mean, if we hit a next intersection, never mind that thought. I'm gonna cut it off right there for a second. So, 12,135. What's this with the same cost? We're having so many things with the same cost. Okay, wait, multiple ways to get Are there multiple ways to get to the same place with the same cost? Should we be considering that in our state? Yeah, that's too many. That's too many. Okay, well, you're halting that. Okay, so visited should perhaps just be of the state, which includes the cost of getting there. Oh, hold on. We also, okay, it's not just visited. Um, you want to make sure it's like lowest cost to get there. So visited, we will just make this the state itself, right? And we just do that from the start. So we filter not was visited. Back to that code. Um, and for each, we only enqueue it if it's the cheapest. just this is just normal Dijkstra that I'm failing on. Oh, I should just really add this to my library, or I should warm up on Dijkstra before day 16 of the year. Okay, so filter another filter. Filter not cheaper. We need to map the cheapest. Wait, no. Visit can in fact be. Let me just undo what I've been doing. Uh, yeah, like this. My point and direction is really my search state, and then val map. Wait, cost equals map dot empty, and we have point direction to an int cost. I don't think it even needs a default value, but we'll let it be. Okay, so filter not visit and also filter that it's the cheapest uh, as to s dot points is less than the current cost given the position and direction. Um, so for each s, we don't just queue, but we update the map, right? Cost. Okay, s dot points. And you want the minimum points. Great. Cool. That should do it. That should finally do it. Uh, as soon as I fix compilers, too many arguments for method update. Um, so, key. There we go. No element to remove from the heap. All right, so we stopped. We stopped early. Uh, what gives? What gives? But we did. We didn't hit an infinite loop. um, we check that the points are less than the current min cost. We'll call this. We'll rename this to min cost. And that's how I normally do it. I would normally like I wouldn't have this set. I would just use the keys of this min cost map. Um, so we can refactor at the end. This can be a bit tighter, a bit cleaner. But let's look at how we were searching and what is our end goal? So end is 139, 139, 1. 139, 1. 1139. Wait. Oh, okay. They're like opposite corners. Okay. We're going to 139, 1. Let's look at the output here. So, how close did we even get before our queue ran out of stuff? It doesn't show everything, so I'm going to put this. I'm going to copy the worksheet output. Okay, so this is where we ended. Is that 657? 657. We ended right down here somewhere. Okay, so that tells me we're not putting enough into the queue. This happens when we're trying to dequeue the next place to visit. We could print what the queue size is at each of these points as well. That might be helpful information, right? So the point we're currently visiting, as well as it knows what I want. Okay. So for a while that we get into the hundreds for a while. We could print an image of that final state. I could have my loop terminate early. Oops. Um, so at this point, there's still one in the queue. Uh, Geez, I wish I could look at that on a map and kind of know where we are. Maybe we are refusing to put things in because of the visited. Let me take a look. So we refuse to put it in if there's a cheaper way to get somewhere, right? If there's already a cheaper way to get somewhere. Well, we refuse to put it in unless it is the cheapest way to get somewhere. And we also refuse to put it in if it's been visited. Okay. What else? That makes sense. We in queue the S. We reassign the min points. So at this point, we're not putting anything else into the queue, I guess. So at 154, 154, like somewhere along this line. So we're like at a dead end, and we decide not to put anything else in. So when we get to some intersection, are we failing to get all the possible places to go? Is it these four-way intersections that are getting me? If we only look at possibly going right or left, but not forward, let me double check that. So when we're calculating our next steps, well, we have three directions, right? Forward, left, or right. Backward should not be necessary. Okay. And these are the costs of stepping into those plus the cost of turning. Um, and we move from the intersection to get this new position P. Okay. Um, and then we do the normal checks on a position, make sure it's not walls, and make sure it's in bounds. Okay, I mean that checks out. We are moving ahead, right? Enter.move in the direction. The directions being the current direction, turning left and turning right. Okay, how about for each of these positions, we print what that intersection looks like. Yeah, let's do that. So, we want the area around. Uh, well, surrounding. Let's do. Um, yeah, let's do that in here. So we want an area bounding. Visiting that pause dot north and then east, and visiting that pause at south and west. And then we will do a draw. So we can just we don't even need to give that a name. So we're gonna do dot draw point. And if point is visiting, then we just yeah, we'll do the O. If walls and that, otherwise we do a dot. I want to do something else too. Else if visited at that point. Oh, in any direction. Oh, wait, what's that autocomplete? Oh, you know what? The fact that my state includes the direction. The fact that the state includes my direction might be problematic, but we'll see. Okay, let's take a look at what this prints. And yeah, same kind of thing. Okay, so I have a clever way to kind of see where I am. And it's by printing the surrounding area there. So here, 154, we are facing north. Um, there's one state remaining. I don't know. Let me pull this 962 off the list. I guess this didn't add. Why would this not add any states? So one. Shouldn't one be here? No, I think I have things. This here is 1-1 on my map. Oh, yeah, one across, 54 down. Okay. Why is the left wall not solid? Okay, let's scroll to the top of this. I want to see what my start state looks like. So our very first visiting. Okay, and we're kind of flipped around, aren't we? Wait, we're flipped around east and west? How? Wait, we're flipped on the side, actually. Yeah. Okay, so we're facing north. Naturally, it pops, it adds this to the queue, or we just are going north, right? And we're continue. Wait, that's the next intersection, right? So north at wait, the next intersection is 6. That's here. Something is up with my directions. Um, oh, alrighty. It is an hour in. GG, well played. Still working on part 2, right? Thanks for stopping by. Uh, should be easy. I felt pretty confident about it. So let's look again here. Start, I guess north is to the right. And this is the next state it does. So it's flipped. It could just be that my draw function flips things, except then why wasn't the tree flipped from yesterday or 2 days ago? I won't dwell on that too much. I think this is probably still working. Well, let me check. So scratch. We are facing east. Oh, right. So it should go east. Um, yeah, and it goes into this looking intersection. That intersection's wrong. No, no, no. That's the spot ahead. So that's this and this. These two should have been added onto the queue. Um, so the next thing from here that should get added. Well, we have the north. So I guess this here is cheaper than this here and moving north, right? So we'd look at the next intersection, the adjacent would be here. So we have this one facing north, right? I mean, yeah, that looks good. Our printing is not showing the direction we came from. So I'm gonna modify that a little bit so that we can see a little bit more information. So if walls, otherwise, and more importantly, I need to rethink whether the direction should also be in my state. Right? If there's a cheaper, it should be in my state. Because let's say we have a goal. I'll just whiteboard this a little bit. So suppose we have E here, and we can get to this position in 2 ways, right? Let's say if we're facing this way, it costs 999. But we can get, if we find another way to get here, where we're facing that way, and it costs how much more? You know, like 1001 or something like that. This is more expensive. Yeah, the point is like it's more expensive to get there, so we shouldn't do it just based on the point. We should do it also based on the direction because this is going to be more expensive once you add the cost to turn around. So I'm still happy with having the direction in our visited set and also in our min cost in our min cost map. Absolutely should include the direction. I don't know why we're not seeing this. Oh, wait. I know why, because the visited is only going to be the intersections themselves. Or not even the intersections. We're not adding the intersections to this map. We're going to the intersection and finding the branches of those intersections. So that could be what's causing me problems. Would be what's causing me problems here. And why might it? So let's say here we're at this we get to this intersection. We look to the left and right. So this state gets popped on, and from here we find this intersection, and we look in those three directions. Um, okay, but we. So this is part of the problem. I've just realized it, right? So because I condensed my search state, I could get, well, when I get to this intersection, I put these three on the map. I guess I could get to that intersection from another direction or in another way, right? And if I do, I'll put, let's say, approach it from the bottom, and I'll put these three in the map. Okay, so I mean, we'd always be placing the same things in the map, which is the branches directly off of the intersection. Um, we could add the cost of turning around 180. I don't think that would make sense because it adds 2,000 for something you were already at and could have turned around from there. But I do suspect something then is wrong with my condensing code for these intersections. I should maybe get only the actual intersections in the map and then count the costs of moving between them. Right. Yeah. So when I'm doing next from some point, what I'm doing next from some point, which is down here, maybe I should look left, right, yada yada. I should do all that stuff from the position and then go from those to the next intersections. That would make a little bit more sense, I think. So we're going to move from our position, not enter.move, but pause.move. We'll filter each of those, and then we add a dist. So point direction and then points plus s plus, no, we don't do that point actually. So val next pos equals next pos and then the distance. Yeah, it's going to be next intersection of P and D. So now here we place next pos and then our direction and then points plus dist plus s. So that changes things up a little bit. Um, it's more sensible and it might somehow magically not have the bug I'm worried about. Oh, hey, look at that. Look at that. 57360. Okay, well, 57360 is too low. I hope that's actually what I typed in. Um, but we ended. Let's take a look what's going on here. So now these states are all at intersections. Um, and let's see what happens when we get to the end. So let's look at, wait, 57350? Did I miscount? Oh, and this would only work if end is an intersection. So I need to be careful about that. Um, let's go around ends in the top right. So end happens to be an intersection, so we're happy there. Okay. So this at 139.11, right? It's 10. It's it's over here. 573. Yeah. 57350 gets added in, and then 57360 is the 10 steps to walk from here, this point in the right, to the end. I'd kind of like to know the whole path to get here. Did we go like from the bottom or something? Maybe at the end we print like all of our states, I guess, where we searched. I'm not sure. I'm not sure. But we do need some more debugging of some sort. Um, this isn't actually going to be helpful because we're not going to see more than one intersection. We don't have an open space. Finding next intersection, pretty confident about that code. Not going to bother debugging it. Next position, next intersection. We could write a test. Alka, welcome, welcome. Thank you for the raid. You know, I don't think I've seen any of your visualizations this year. You didn't do anything. What's that supposed to mean? You didn't do Avena code? Let's see. Well, I just fixed my performance issues. Um, well, okay, Dijkstra, I messed up a little bit on the implementation. I forgot to add, this min cost check, and for a second I was forgetting to check if a point was visited. I got those out of the way, and it was too slow. So I condensed the graph. So instead of just doing every single state, we just do the next intersection as our next states that we're popping into the queue or pushing onto the queue into the queue, and then that now works, and I'm getting the wrong answer. Um, right, I tried 57360. I'm pretty sure I tried 57360, and it was saying it's too low, which sure. Like how wide is this thing? That means like 57 turns. 57 turns and 360 movements, maybe. Um, yeah. My approach here, so for everyone just joining, I have this is a classic Dijkstra. I have my start state, which is my position, direction, and the score. My state includes a score. You can do Dijkstra. This is honestly probably better if you didn't include the score in the state, but it was easier to calculate the next states doing it this way, right? So I keep track of visited points and directions, and a min cost map given a point and direction, um, and it's ordered by that score or with that score, and then the priority queue is ordered by that score, right? Maze of twisty little passages. Is it dark? Is there going to be a grue? You were going to do Dijkstra, then my mind melted. I mean, what I should do when I hit Dijkstra is just copy paste a previous year. Um, or honestly, I should just add this to my library. But it feels good to write it and know that I can, I guess, from scratch. Okay, what do you see after you light a lamp? Should I be lighting lamps here? I do kind of have lamps. So at each state that I put in, I print the surrounding area. I could do more surrounding area. It has honestly hasn't even been that helpful. But at least we're not running out of states in our queue. So here there were 76 more to check. And there's no way. So am I possibly misprioritizing? So is it possible that another state in my queue? Well, my answer's too low. I'm getting there too fast. So it appears maybe I'm not adding enough score. So that's the first thing I'm gonna check actually. I'm gonna check what I'm adding. Wait, Twitch sends you are in a maze of twisty little passages all like when you connect via IRC. Oh, that's funny. Okay, so looking at this, um, if my score was too high, that'd be a different kind of bug, and I'd be like, oh, my prioritization's wrong. But my score is too low, so I think it's just adding points is wrong. So here's my next method. We have, oh, what's this? We don't need this anymore. Let's delete that. Maybe that's a bug. Okay, so we have the three possible directions, right? And the cost of, this is the cost of stepping in each of those directions from like an intersection. But let's ignore what we're zipping for now. I think that's probably wrong. Um, maybe. So we take each of our we have our directions and we move in that direction, right? Let's draw this on the whiteboard as we're doing it. make it visual, and maybe I'll see my bug. So we are at some position, and we have a direction. So we then start looking at these 3 points. So this point in that direction, that point in that direction, and that point in that direction. Okay. And we filter those out, make sure that they are not walls and they are inbounds. Cool. Makes sense. Um, then for each of those, we look for the next intersection. This next intersection assumes we're already at an intersection. So it drops the first one. So that could be a bug. I don't think it is because I don't think we have two intersections like adjacent to each other. But it searches in that direction for the next intersection. And this here is probably an intersection itself, right? Like these are all walls, and we came from here. Um, so we search for a next intersection. Um, I don't know. Maybe we have some like hole here. So we get and we get that direction. So that's this next pause here. And the distance is, what is the distance going to be? I need to double check what that distance is that I'm adding there. Um, but if this already counts for the 1000 to turn and the one to step here, then we only need to count like, 1, 2, 3, and then like the very last bit. So I'll double check that. So we do that, same thing in each direction. This might be like shorter or longer. I don't know. And those are the the 3 states that are at intersections that are reachable from this position, right? So I hope that makes sense. I don't want to be spoiled on the puzzle, but I do want to be told if I'm saying something stupid. So feel free to call me out if there's a mistake there. So next intersection. Um, we zip it with the index. Right. So this here would be 0, 1, 2, and then 3. Right. So we get the very last one. Well, let's see. We're dropping while there are walls on the left and right. So we drop this, this, and we take the next, which is this. So we get this position and this index. So, well, what do we do with that? Let me zoom out there a bit. Yeah, that position and that index, and then down here, that next position is what gets added, is what becomes part of our state. It gets added to our queue, and the distance, so that 3 gets added to, oh wait, the distance here. 3 would get added to S, which in the case where we are moving straight is just 1. In this case where we're turning left, in the case where we turn left, it's 1001 because we turned 1000 here to face north, and then 1 to step into here. Yeah, it is off. So 1, and then it needs to be 1, 2, 3, 4. Yep, yep, that's the bug. Um, I don't know, like the distance is still. I don't think we should be moving. So we do a pause.map, move in that direction. We're doing this at an intersection, so we don't need to move in those 3 directions. I mean, that tells us if we're walking into a wall or not. So I guess we want to do that. We'll just add the 1. So this is 2, 2, 2. And we can rewrite this in a way that's clear. Make more semantic. So we'll leave that as a to-do to refactor. And let's just run this again. And since this should be a bigger number, that's probably it. 57483. 57483. 57483 is still too low. Okay. Um, okay. Still too low. Uh, but it is higher. So it is a bug we fixed that we made that went higher. Okay, so that distance we're measuring, is it really a distance? Well, from here you go one, two, three, four. It's not really distance. A distance from here to there. Um, shoop, shoop. We'll keep calling it distance. It's a space between these two. Um, but we're still too low. So what else could be an issue is the fact that we are stepping here and then searching for the next intersection from here an issue. It would be an issue if there were an open space where we are already on the next intersection. I'm going to drop this drop one. We don't need to drop that. So this starts with, yeah, this starts within an alley of some sort. I don't think we have any open spaces. Let's do, I don't know, this is easier if we highlight this. Ooh, yeah, there we go. Yeah, everything's narrow. I'm pretty sure. Uh, let's check again if we're still working on the oh, you know what? This code that I modified did work on the example at some point. It's probably no longer working on the example. Yeah, 11048. Okay, when was it working on the example? What did I change? Um, so I was working on the example and I did what? It was it was failing on the real thing because it was too slow. Is that the point at which I tried to condense things? So I think this would work on the example if I change this to 1001, yada yada. And this here, um, we don't do this next intersection stuff. We just do points plus S. Next pause just becomes P. Okay. Yeah, that's what I was working on the example. I guess I should condense my graph in another way. Wait, wait. It's working now without any of the condensing? Why wasn't it running wrong? I don't know why it wasn't running earlier. Okay, well, I had a correct algorithm at some point, and apparently the algorithm was efficient enough. My attempt to optimize it didn't do anything, or just introduce bugs. It's, it's Dijkstra that said premature optimization is the root of all evil, right? I don't think it was premature though. I was pretty sure it was not working. Thank you, thank you. I yeah, I'm perplexed. I'm pretty sure that this code wasn't able to run on this, which is why I added all of this Optimization. It must have been something else, like some small bug I fixed. I don't know. Okay, whatever. Part two. We'll get a good split. Now that you know what the best path looks like, you can figure out the best spot to sit. Non-wall tile is equipped with places to sit along the edges of the tile. How those seats are, how far away from bathrooms, whether the tile is on one of the best paths through the maze. Okay, so we want the tiles that are on the best path. I don't have the best path. I just have the cost to get to the best path. So we'll need to modify that code. 45 tiles marked part of at least one of the various best paths to the maze. Why would there be various best paths to the maze? How many tiles are part of at least one of the best paths through the maze? Wait, why are there more than one best paths? Oh, wait, okay. I see. There could be multiple that share the same cost. There could be multiple that share the same cost, and we want all of them. Okay. But now each state needs like an ancestor. Does Scala sound like a supervillain organization? Maybe. It does sound vaguely European, and James Bond supervillains are always European, right? But wouldn't the supervillain organization here be Oracle? Hmm. Okay. So, whatever. We had codes working I don't know how long ago. I'm just, I have bad attention to detail when I haven't been sleeping that much. Um, I'm gonna delete this because I'm mad at it. I might regret deleting it. No, we're definitely gonna not use it for part two, so I don't regret deleting it. Um, so we should be storing paths instead. So min cost to get to a point shouldn't be just an int, but also the path to get there. Int and a list of positions, which there was never too much in our queue, right? I think I have enough memory for that. I hope I have enough memory for that. Can I do that? Uh, Let me think. So we had this print line and we had the queue size. Well, min cost size. Let's do the min cost size as well. Um, what did that run? Okay, so we'll copy worksheet output and we'll look at some of those values just to make sure um, this won't kill us. So by the end, we have 14,000 in there. So if a path on average is going to be like a couple hundred long, 14,000 times a few hundred, no, it's a couple orders of magnitude. So like a million. We're going to be storing a million points as elements of a list. Maybe we don't do it that way. maybe we map each to a state. We map each state or position. Now we that is kind of its ancestor, right? And we just traverse that map back. So step one, we're trying to get a path. So let's do this. Val path equals map from point direction to point direction. And this can be an empty map to start. And we'll call this a path back, just so it's more clear what the intention is. Okay, so every time we enqueue something, so we have some valid state, we enqueue that state, we add it to the min cost, and we track the path back. So path back is that. One of the, I mentioned earlier that my state doesn't necessarily need to contain the points, and this is why I would like to do that refactor. Is because I keep having to do this dot pos and dot direction. Right, like everywhere. I'm doing pointer everywhere. I should just be writing state there. Like this thing is kind of, like that includes the points. I don't ever use that state type anywhere. Anyway, we have a path back. So now once we get this visiting, let's also just print the I don't know, let's return the state and the path back as a list of points. So the points on that path, rather. Hmm, hmm, hmm. This maybe we shouldn't call this a path back, but the from. Well, anyway, we're gonna make a path until we hit the start again. So we're gonna keep recursing. So iterator dot iterate, starting from the visiting, I guess. We are just gonna do path back for sub, and I guess we just iterate all the way through, and that can be a list. Dot to list. Um, and then dot reverse. I suppose we could build a list. I don't think it matters too much. So we're gonna reverse that. And we're also gonna we want a map on that. So all of these states we're just gonna get the position. So now we return that and the path. Oh, yeah, path back takes wait. Yeah, it takes a point and direction. Um, right, we start with visiting dot pos and visiting dot dir. And I guess we're not doing this with S. We can just iterate using path back. Oh, wait, is that right? There we go. So we just get the left-hand side. And there's some key not found. Okay, we can add a take while. Dot take while not equal to start pause. So we just missed the start pause. Yeah, the path's not going to include the start position, so we'll just keep that in mind. Wait, what's this? So this is our winning state, and then the path all the way back, which does not include, oh, it does include the start. Really? Okay, but we don't want just one path though, right? We might have multiple paths through here that have the same cost. So how do we do that? We need to, I guess once something matches our end position, we could add it to our list of end states. Well, thing is add this less than. I guess I should do less than or equal. So if it can happen at our end position, it can happen elsewhere, like right here. Apparently there are two ways to get here to this position with the same cost, right? Um, so the state, the way I have it right now, I'm going to have a unique path back, but I should keep track of all the paths that get here in that cost. Um, okay, let me think about that. Um, okay, so we take our next states. We have um, in keto states, we add it to the min cost. I guess it's less than or equal to. So I guess position and direction. Actually, once I get here, so thinking back about this bit again, so the way my algorithm works, if I'm walking here from the east and I get here, I'm going to add a state here that is 1,000 less than the state going from the north. It's kind of the same cost as coming from the west, if that's even a thing. Could it be a thing? Could possibly be a thing. But yeah, we update it to those points. Now in our paths back, so paths back is now multiple, and we have a list of point and direction. And yeah, the direction is all we need to get back. We don't really care about the score cost to get that way. Um, and let's do a with default value of an empty list. And instead of saying the path back is there, we are going to we're going to say it's its current value onto the previous value. And I guess it's now paths back with plural. And this paths is now a flat map. So we have a list, I guess. We don't even need the particular paths. We just need all the points that are in here. Yeah. So basically all the concept here in in paths back and get referenced by these. So let's do this. Let's do this differently. Um, we start at the end position. We're on TV. Hello, hello. Good evening. Have you finished? Are you streaming tonight? So point to direction. Yes, at each step, we just start with our end state, and at each step we flat map. This is an unfold. So iterator dot unfold, and our initial state is kind of our set of positions from which we are searching backwards, right? And that set of positions to start will be, oh, and let's make this a set. We'll make this a set because oh yes, we'll make it a set, and it is the visiting dot position and visiting that direction, right? Executing part two was tough. I had the concept right away. Yeah, I don't feel like part two is tough. Part one just took me too long because I don't even know why it took long. Like I had the solution, and it worked fine on the example, and then it wouldn't complete running on the real problem, right? So I started adding some optimizations, um, and those optimizations weren't working. So I deleted those optimizations, and then it was working fine on the real thing. So I'm gonna have to comb through this video and figure out what exactly happened there because it perplexed me. Like once it was running, like it was running instantly, I was getting the answer. Like maybe I got the answer and I didn't see it, which would be a thing I would do. Yes. I mean, that happened to me literally 2 nights ago, right? Didn't I have the answer like 2 hours early? Ah, oh, we are missing some music. I'm gonna shuffle this. Okay, so we have a position and a direction. I don't think we care about the individual just direction actually. So we have a state, and we do s. Well, we do has back on each of those. So what do we call this? Well, this is let's call this states. So you have multiple states. States dot flat map with paths back, and that should be a new set, right? And then at the end of that, we just map to position. So dot map. Um, so I guess we're calling this seats now. This is seats. And since that's a set, we just do that size. So this needs to we need to make sure it's a set. Found. Oh. Um, since this is an unfold, we do it this way. And that's always going to be, we're going to keep doing that as long as there is something. So option dot while and dot non empty, we do that set. And is n itself a set? Okay. N just means next state in this case. And we have some issue with the syntax. Mm. Sure what's going on here. So with this new Scala 3 indent syntax, sometimes there's an error, a syntax error down here, and it just gives an unhelpful message. Identifier was expected, but val was found. I don't know, buddy. Just change up our syntax. We're missing a parenthesis somewhere. We must. It's the USB stick problem. Try plug. Yeah, exactly. Okay. Well, good luck with work, or good luck sleeping forward. It's good to get a good night's sleep after having a code. Oh, option not while. I see. Option not when. Okay. That was that's not a method, that's a keyword. Pause, we just want one. Okay. So seats and okay, this isn't the solution yet because we are halting the search early. Um value. Oh, hold on. What do we have here? So we have like a list of sets. We just want the final sets. Okay, we take our states, we flatten out with the paths back. Um, that gives us new states. Sure. Flat map, and then distinct.size. No? Oh, right. We still have that. Yes. So these are sets. You just want to reduce these sets with a union. Um, and then map to get the position. Reduce. Reduce. There we go. Okay. Great. So 396 is the number of seats, but we have we do terminate too early. Visiting that pause equals end pause. Um, let's do a target cost. So at some point we'll find a target cost for the position, right? Val and cost. So let's make some var. Let me start at integer int.max value. um, and visiting is a state. So while visiting that score is less than or equal to end cost, we keep looping. And that should be easy. Wait, is it not score? What is it? Points. Okay. Oh, whoa. Don't run. You don't want to run all the way to the end. I guess we could run all the way to the end. Well, we're going to terminate early because we can, and it's easy. So when we hit the end position, if visiting dot position equals end position, then we set that. And I think if we're going to use if as a statement, you have to use this kind of old syntax here, and it looks more like a statement and less like an expression. Um, I don't really need that anymore. That might be helpful. Okay, let's try it. So 289, how many tiles are part of at least one best path through the maze? Am I going to be off by one here? Am I missing the end? Um, yeah, let's do this. Uh, and then let's assert I don't want an off by one. Seats that contains end pause. Seats that sides. Okay. Okay. Cool. So we're just gonna add +1. Um, we're being hacky, but this cleans up well, I promise. I'm gonna do cleanup after this. That's gonna be nice. Okay, answer's too low. 290 seats part of that. Well, let's print those positions. Area dot draw. So if seats contains P, then yeah, we'll do an O. Else if walls P, otherwise dot. Sure. Um, let's add another else if. Well, no, I don't care. We know the end will be missing there. Um, yeah, let's take a look at that. Oh, I want to look at it on the example, but while we're here, let's see what it looks like on our problem. Okay, so this ran, right? Oh, wait. You can't just draw. We have to actually print that. So area.draw only gets me a string. Mm, Hola, we dumb boys. You have no experience in Java whatsoever. Yes, you can totally just jump into learning Scala. In fact, I actually feel like, I definitely feel like learning Scala is easier than learning Java. It's weird. So Scala has a reputation of having like a high learning curve. I think the language is simple. Like it has been used as a teaching language. Like the specification for Scala as a language is smaller than the specifications for a lot of other major languages. And it starts with simple concepts. And I think the reason Scala has a reputation of having a high learning curve is because there is a high skill ceiling for things you can do with it, right? You can get into the weeds. It gives you a lot of power. And those things can be a bit. Um, Learning functional programming, I guess, is its own learning curve. So in that sense, maybe I don't know for like a beginner who's never programmed at all, I feel like immutability might make more sense, right? You learn math in school, you don't expect variable variables to like change, right? Yes, you say like say x is 13, you don't it's not suddenly 14 later. So I think Scala is actually good as a starter language. And if you I can I don't know. I can recommend you books or whatnot. Like if anyone wants to learn, I'm happy to help and you can always get me on Discord. Um Let me see. What was I going to do here? I'm going to print this. Yeah, let's take a look at that. Copy worksheet output. So the issue here is that we only have one path. No. This path ends early. Are we still getting the right answer from the part one? 86289. Okay, let's look at that. Oh, okay. I changed the code and I'm not getting the wrong. Wait, what's 290 even? Oh, right, because I'm searching from the wrong uh end position. Okay, so we need to search from end position and end cost. Search gives us a state. Um, yeah, the direction doesn't matter on the state. So we shouldn't do visiting. Let's just set a first winner, I guess. No, no, no. We're not returning state at the end of this. We're returning uh, a point. We don't care about direction. We're returning a cost and the number of seats available. We don't even care about the point actually, because it's just the end position. So we want the cost and the number of seats available. Um, yeah, and cost. And now here we're searching from visiting. We should be searching from end pause. End pause. I think we just iterate over all the directions. No, we're just going to do north and south. So end pause to dir dot north and not facing north and also facing west or east. And pause to dir dot west. It would work if we did all of those. I should just tab completed. Okay, we're back getting the right answer. And 397 for part two. Okay, 397. 397 is still too low. I guess this is ends one, ends two in one thing. 397, too low, part two. Did you forget to add one? Nope, seat set size. Well, let's at least print it. So take a look at how this should change. I should have done this first, actually. I just felt pretty confident. Okay, so now we're getting a path that reaches the end, but we are only getting one path. Okay. So our search, is our search stopping too early? Um, let's look at this while. Um, while visiting that points is less than end cost. I hate points here because it sounds like my point class. I wish it was just score. I should just rename it for myself. Or call it cost. So visiting that less than or equal to end cost. So at some point, if we're at the end position, oh, we can only do this once. If visiting that pause, let's do this. If visiting position is the end position and visiting that points is equal to end cost, then we do that. Then we, because I think what we're doing is resetting end cost multiple times. See, I can't think in terms of mutation anymore. No element to remove from heap. Oh no. Now we're terminating too aggressively. Oh, wait. Yeah, we're not setting an end at all. Let's say and end cost is not max value. So end cost, we say end cost hasn't been set yet. Okay, that's what we're doing. Try that. Wait, still? So this causes us. We set it. Oh, no, no, we set if it's equal to max value. Okay, if it's still at the max value, it hasn't been set yet, and we are at the end position, then we set the end cost. Jeez. Okay, well, I'm still getting the same answer, so maybe my search for the paths is wrong, but let's at least see. Well, I don't think it'll have changed. Yeah, it's still the same. Okay, let's keep tweaking our termination condition then. So as long as visiting that points is less than end cost, we continue searching. So the problem is we find one and then we somehow stop searching. Okay, when it dequeues, it should dequeue things at the same. Would it dequeue things at the same cost? Okay, I want to see what will be dequeued next. So after this, I don't know. We're just gonna DQ 10 times. Um, Awarahoon, thank you for the raid. Party of 8 viewers, welcome, welcome. So we are on the verge of getting. I assume you're all doing admin code. We're on the verge of getting part 2. Um, I do have it where I'm able to highlight the path, like the first path I got, and I'm altering my termination condition, so that also includes the other paths. And I thought I had it just a second ago, but I think I have to debug just a little bit. You're failing badly at it. Oh, did you give up? Oh, I see. You're behind on Avena code. So what were you working on then? So let's take our queue and let's just dequeue. I don't know. Let's do that. There can't be more that many paths. So let's see what's next on the queue afterwards. All right. So we had all of this. This was while we were searching, right? And then we have a bunch with this cost. What is $7.99? I can't remember what that is. And then we finish, and then we have more states. 86289. So we had a couple different states with 85359. But they're wait, these are all facing north. Why was it DQ'd multiple times? Let me look at what the rest of my debugging means. Which algorithm am I using to find a path? This is just a normal Dijkstra. Um, I could do a quick tour. I see. Well, since y'all weren't doing admin code, um, just now, I could give a quick tour of the problem, and maybe while I'm doing that, I'll find my bug. And I do want to do a refactor of this. Anyway, we have a maze that has these as walls, and there's a start and an end, right? The rules for this maze are that moving forward is a cost of 1, turning right or left is a cost of 1,000, right? So this is where I calculate my next states from a single state. We we have our 3 directions that we're turning. We move in those directions, make sure that that new position is not a wall and inbounds, yada yada. Um, and here's a typical Dijkstra's min cost map visit set. Again, there's some redundancies here. I can make this a lot cleaner. I'll refactor that afterwards. And now what I've introduced for part 2 is this paths back map. So every time I hit a new min cost point, I save it, and I save, I add to its list of paths that reached there, right? So that gets used here. So this is us getting the next bit. We do some filter, make sure it's not visited, make sure that the points are less than or equal to the current min cost. And it's less than or equal to because if it's equal to, we're going to be adding it to the min cost, right? So min cost equal, wait, what? Min cost equals s dot points. This is wrong. I forgot to delete a line. Yeesh. Okay, well, no, no, no. Min cost is correct. So we set the min cost. It's gonna be less than or equal to, so that doesn't matter. Like there might be multiple costs. Now we add that path back, because this is a min cost path there. We say where it came from. So we add visiting that pause and visiting direction onto paths back for, oh, no, 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 no. We want paths back for this position, s dot pause and s dot direction. Right. Uh, yeah, yeah. The place we came from is visiting, so we're adding that to the list. Okay, okay. I think we just fixed a bug. So we don't need to do this stuff. Well, I mean, you can just take a look at it. 441. Let's just try that. 441 is too high. 441 too high. But let's at least look at the drawing there. You've got to go get ready for work. Makes sense. Well, I hope your stream was fun. And yeah, good luck. Get some sleep. And good luck catching up. Okay. Let's see what this looks like now. I should just print different characters here that are like that pop out on screen more. Oh, we're still seeing only one path. Are we? Yeah. Somehow that's longer. Hmm. Okay, so how are we getting these paths? Actually, hold on. I want to look back at that debug a little bit more. So at this point, you guys should keep track of how many times we've reached the end. I could use that as a debug. Yeah, let's do that. Far and reached equals 0. And I don't know if using that pause equals end pause, then end reach plus equals 1. Whoops. And let's print that. Finished, found, and reach times. Okay. We found the end 8 times. So there should be 8 paths through here. And we know what that is. We know that we found it 8 times. So that tells me the bug isn't in our search code here, it is rather in our code that figures out what a queue, which those seats are. Um, Let me see. Let's do dir.values dot map. So we have a direction, and we're going to do just an end pause and that direction. So this is where we start our search. So these are our states. Um, and for each of those states, we check on their paths back, right? At each step along this. And as long as the paths back aren't empty, then we add those new states. Right, for each state, we look at its state, the full list of states that leads back to it. So, is it possible that what it seems like is happening is in this pass back? So, this pass back again is a map from a state to a list of states. We are overriding it and adding 1 to it. So, it should be whatever value is currently in there, and we add 1. It feels like that is not ending up empty. I could probably write this in a clear way. Maybe when I write in a clearer way, we'll reveal the bug. Um, first, let's rename this. So this is our next set of states. Okay. And this is our starting set of states. We have an issue with this. TwoSet is not a member of. Oh, wait, did it just never run a new version? And when we're searching backwards, it should always be. Yeah, it's only gonna be non-empty if we're looking from start, or if they're like all at start already, because still trace multiple at a time. Right, right. Um, we're just gonna turn this into a space. FC contains. I'm happy with the O. Let me see. What's a Unicode block? Oh, look, I was just asking for a Unicode block. How does Copilot know what I'm about to do? I don't know. It's magic sometimes. It's goofy a lot of times, but magic sometimes. We haven't changed anything though. Okay, let's do an assertion. Let's say paths back There should exist at least one that has a branch, right? Let's count. Let's look at the values. Values. So these are all the list, and we're gonna count these lists. Is greater than one, and there should be at least one of those. Let's just print this, or yeah, let's make an assert. Um, this is the number of branches. Branch count. So let's assert branch count. Actually, let's do it this way. And we do a message. Oh, hold up. That's not what I want to write. So we assert that branch count is greater than one. Number of branching places, or greater than zero, rather. And I don't know, let's just use the branch count as a message for now. Say greater than 100. I want to see how many branches there actually are. That should make it fail, right? I guess there are lots of places with branches, same like multiple costs to get to the same place. We could count seats as we're getting somewhere. So we could also count. Well, no. We can't count seats because we need uniqueness. So we do need to actually track the particular seats. Well, let's print our branch count. All right, too much debugging info in here. Yeah, that has to be copy pasted. Okay, so there are, in fact, actually lots of branches. How many of those branches get hit on the way back from the thing? Oh, wait. We are showing multiple paths. So here's some multiple paths being shown. Okay, well, maybe we're just not getting enough paths. I mean, okay, before we get to the end position, we should already be trying to branch off of stuff that has the same cost, right? If we had two ways to get somewhere, we're pretty much immediately going to try and branch off in both those directions, right? Like we'll try here, and that's no longer the lowest cost states. Then we'll try in the other direction. Or I mean, once we get to this turn, we try in the other direction, right? Um, so by the time we get to the end, we will have found those. You know what I should be doing is testing this on the example. I kind of suspect it'll work on the example and not really give us much to go off of. Oh, we have, is that an assertion error failed? Yeah. We don't even need that assert. Okay. This is what we get, which, if we return to day 16, is the same, right? This is our output. Two paths exactly. Okay, what's our ans 2 though? Did we miscount that somehow? Ans 2 is 64. Okay, we miscounted. Okay, so we correctly identified the seats. These are the seats. Oh, you know we correctly identified these seats because when you print them all, the correct ones show up. Um, but when we do CSAT size, and the plus one there is for the end position, which isn't counted. Ans 2 equals 64. But this map clearly shows more than 64. Oh, wait, no, 64. 64 is correct. Okay, so we get the correct answer, and we print the correct image. So there's something more insidious happening then. This is my least favorite kind of bug. Um, we tried 441. 441 is what we get when you go back to the main problem. Right, in this case, ans 2 is 441. And 85396 is ans 1. That's still correct. Okay. Let's print that again. Um, I mean, so I'm confident I'm counting these. I am managing to get multiple paths. But say, why would I miss something? And can I see something that shouldn't have been missed? Right? Are there any 2 points here where there's like multiple paths from one point to another point? Let's just count that in another way. We're able to print. Well, no. I'm I'm gonna give this a new symbol. Well, I was thinking about getting that a new symbol and then searching for it, just so I can quell my insanity. Like, surely, my count of these seats is correct, right? We're not having like a duplicate or something, and I know that because it works fine on part one or on the example. So we're not running into like an issue with duplicates there. I feel pretty confident that our seats that we're printing are all counted. So the issue then is probably that we are missing some seats. I mean, I don't think we're missing any seats in the paths that we find. It's probably, it seems like maybe we're just missing some paths. I had 8 paths. That means I had 1, 2, 3 branches. And at that point, everything on the priority queue was higher cost, so there's no point in searching from there. Oh. I don't know, man. Anyone have ideas? Is this almost always going to be like a power of 2? like the number of paths. Am I out of ideas? Do I need to sleep on this, rewrite that? Okay, I'm gonna give myself a mental break from this by doing a little bit of a refactor. Let's clean this up. Um, we'll make the code nicer to read, and maybe in that case, we'll find a bug. So I was gonna do this refactor afterwards, but afterwards is seeming further and further away. Um, so next, I think instead of a list of state, we're gonna do a list of state and cost. So we're gonna move the points outside of here. Okay, there's that. And a lot will change with that. So our start state can omit this cost. Visit is now a set of states, and it's just start. Min cost is now mapped from state. I'll keep that default value. I don't think we'll need visited, because we'll know if it's visited because it has a min cost. In which case, if we're going to use it that way, we need to remove this default value. We don't need a default value. Okay, and the priority queue starts empty. I'm happy with that. Min cost is not going to start empty. We're going to start with start to 0. Yeah. So pass back is a map from state to state, or state to a list of states. And with default value nil, that is fine. Visiting equals start. Sure, sure. Um, let's set end reached. No, we'll leave this stuff for right now. We'll continue with the state refactor. Instead of ordering by negative points, we're going to do ordering by map, or min cost. Ordering by min cost, reverse. Yeah, I'm happy with that. And state, I don't think we ever modified it actually. So this next, oh, it still has points, so let's get rid of that. I guess we don't add 2 points. We just now have the delta. Sure. Now going back down here, we're still fixing things. I'm gonna rename. Oh, no. So states, and we just filter. Our filter not now becomes. I don't know. It's not a key. So not min cost dot contains. Oh, hold up, hold up. I don't think we want that. I think we found out what our bug is, right? Because we are avoiding states that have been visited, but we might want to visit that state again with a different cost. Okay, so we don't want that. The only filter we want, min cost get. No, no, we have the next state and we have the additional cost, right? I'm gonna start saying cost instead of points. Um, and we want to make sure that our cost, well, min cost of the current state. So min cost of the current state of visiting plus C should be less than or equal to min cost of our next state, S. Okay, and now for each of those states, we enqueue them. All right. And min cost at that state equals S dot points. Sure. Hold up. Min cost S dot getter else. If there's no min cost, so this can be empty here. So we gotta take that into account. So we're gonna do dot get. So I guess min cost for all if it's already in there. So min cost dot get dot for all. Um, if it's greater than, then we update. Then we have something to update. Okay. So we get the minimum cost, and it should be greater. Okay. So that should work there. Min cost equals S dot points, and this pass back. So pass back is now state to state. Let's just change that. Oh, it is still a list of state to state, right? Oh, I mean, we already changed it. So pass back from S equals visiting. Let's add to list a pass back for S. Okay. That cleans things up a little bit. Um, so, um, so min cost S isn't S dot points visiting. And oh, hold on 1 second here. So now we have a set of actual states. Okay, I guess. Oh, this doesn't need anything, actually. Hmm. Search doesn't need any arguments. Okay. And we have a key not found at some point. Oh, right away, right away. Okay, a key not found in what exactly? Oh, hold up. In the priority queue. So, our priority queue now uses a where is that? Um, right, our priority queue uses a mutable map. So we have to add things to the map, add new costs to the map before using the priority queue. Um, so we can't enqueue that until we've added it into min cost. Okay. Hey, now we get 410. We get a new answer. 411 was too high. 410 is probably it. Great. So I just re-implemented it, and the second time is wait, 85396. My part one is still correct, right? Yeah. Okay. So 410 wasn't it. Um, 410 is wrong. It won't tell me if it's too low or too high, so I can't binary search this. Um, I think we're making progress because this code feels more correct. I've just written it freshly, and if 441 is too high, let's see. Let's see what our map looks like. And let's see if we're getting the right answer for the example. It should be 64. Oh, now that's too low. Okay, our new implementation is wrong with the example. Our previous one was correct on the example. Let's take a look um, at the map that's printing. So let's go. I actually want to see the big map. While we're here, let's take a peek at the little map. Okay, we're back to one path. I see, I see. Um, Now let's take a look at the big map. Okay, and yes, we're back to one path. Oh, no, no, no. There's a branch. Okay, I see a place where we have multiple paths. You see this here on the right? I really gotta print that with different colors or something. I don't think it's super visible. Let's do this. We're gonna swap the solid blocks. Okay, so Unicode solid block for the piece of a path, and we can use O for the walls, or I don't know, we'll just go back to using the pound for the walls. Okay, we have a branch, and I don't think that branch is even correct. Let's see, from here, we have, presumably we were going to the left, right? So we have one, two, three turns, and one, two, three turns. But number of steps, this is going to be like a minimum number of steps. This is going to be extra by one, two, three, four. Okay, so we've messed something up. I do want to refactor this and search. We, our part one is still correct. So we are finding one. We're finding at least one. I think the others that we're finding after the fact might be incorrect. Um, So let's have the end reach value. And we'll continue searching, continue adding things onto the queue as long as we haven't exceeded the cost, right? So I'm happy with the statement here. Now, Michael PC Gamer, hey, um, how is it going? Well, we did a little bit of, I got an answer as too low, too high. So I had something that works for the example. Um, wait, 441 was too high. Oh, hold up. Maybe I could have like manually fixed that. Yeah, I got something that worked for the example and then failed on the real thing. And we've been back at that point a couple of times. So we did get something that was too low, too high, and 410 is just plain wrong. Um, Let me go back here though, because do we have a previous solution? Okay, like here's an example of a previous solution. I think this is the one that was giving me 441, but too high. Let me see what the answer was here. Yeah, this is giving me 441. And too high, I failed to think about looking for paths that are incorrect. So these two branches seem correct, right? This branch here is kind of fishy. So we'll examine that. This branch, where's the third branch? You're struggling on part one. DFS doesn't work, but only for example. Well, DFS might be your problem. You might need to use Dijkstra here. Um, I mean, that's honestly probably it. Is that well, do you get to the end? Actually, maybe DFS works here. Maybe this isn't so big that DFS wouldn't work. So you are getting to the end. It's not a performance issue. Um, and just to confirm, I am still getting the correct part one. Okay. It's just that for part two, when I'm considering other ways to get to the end, I'm considering too many. Oh, here's what's going on. I think I just figured out what it is. So when I'm looking for paths back, the path back doesn't include the cost, right? So I might have had a path back from some route that didn't end up making it to the end. And when I start searching from the very end and searching through all those paths back, I count too many seats. Um, because I see one of those branches that aren't actually part of an end path. So I know what my issue is. I absolutely know what it is. Um, Weird that I'm getting 410 though. And actually it's no longer working for part one because we've changed how yeah, we've been tweaking how we decide to end. Um, okay, let me check what we do at each step here. So with each of these next possible states, we have a state, we have the cost. We get any possible existing cost. This here might be, I'm going to change this to an if else. Um, I don't like using for on option. It's not always clear clear code for like people to read, even if you're used to it. Oh yes, I'm in part two. Um, so if there's no min cost, let's say let's match the min cost. So what let's get the current min cost. So if there's none, then whatever, we're good. If there is some min cost, so let me check. You have to check if the cost to get where we are so far plus our little delta. Oh no, plus c. No, hold on. Min cost at get s. Yeah, the cost to get to where we are so far plus mc plus m. mc plus m is going to be the new cost, right? Min cost to get to s plus c, whatever our delta. Or rather mc plus c. We, we are going to go ahead with this if it is less than the min cost of where we are getting. Hold on, this is MC is a current winner. Um, yeah, we'll just call this current min. So if min cost to get to where we are so far plus the incremental cost is less than current min, right? Okay, I don't think that changes anything. Uh, right, you should still be getting 410. But it's more explicit. I hope that's easier to read so you can follow along. So for each state plus our cost delta, we say the min cost of the state is min cost of visiting plus our delta. Um, and then we enqueue those states, and then we add to the paths back. Okay, but here's the case where we're no longer working on the example. Let's take a look at that. Because we are only doing one path now instead of two. We should be taking this one that's to the right. So I do want to get a count of our end reach. Yeah, let's print that. Wait, branch count? What is branch count? I guess so. End reached. We never print end reached, so it's just a print line end reached. And that's the number of times we branched, and that's just going to be 0 right now. I use local definition, other issues, okay. Yeah, so we stopped searching. And I feel like we stopped searching because we're not queuing something properly. So our filter just says, just checks if there's like a min cost already. Standard pointer, hello. Welcome, welcome. How is your advent of code? Um, Cost visiting plus C. What am I even? My brain is so done. Let's get these explicit names. We'll rename this to state. Oh, wait. It's not. It's not working. Oh, I guess it kind of did. Let's call this the cost delta. Okay. Um, let's say if mint cost that contains the state already, then our filter needs to check if the min cost at the state is, or the min cost of visiting plus the cost delta is less than or equal to. Oh, that's why. It doesn't have to be less than, it has to be less than or equal to. Else true. I'm gonna leave it at else true for now, but I don't like saying else true. You haven't done any of it yet? You fly home for holiday break on Friday and you're gonna do it then. Fair enough. You don't mind getting spoiled in the meantime? I don't think there are any particular insights in this problem, so there's not really much to spoil. It's just Dijkstra. We do a Dijkstra. Okay, we're back getting the correct answer there. I just flipped the, I just turned the less than or equal into a less than. And we're back to getting 441, which is too high. Okay. Okay. And let's look at why it is too high. And it's probably this thing right here. I'll examine that. Yeah, so we have this branch that looks good. This branch looks good. And this branch looks good. This one here, though, so we start facing north. We turn 2, 3, 4, 5, 6, 7, 8. We have 8 turns that way. And going north, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 turns. Okay. And then now, remember when I said I think I know what my bug is? I do know what my bug is. I just had to fix that other bug that I introduced into Refactor. And it's here. When I'm going back, I'm getting too many of these. So in our paths back, we also have to keep track of the cost. Right? So I guess this is state plus cost. 10x programmer, welcome. You couldn't solve part 1 so far, but then you pasted the problem to Claude and it solved it. I believe that. This problem doesn't take any particular insight. You just do it extra. Okay, so in our paths back, it's not just a state, but a list of states, and the key needs to include the cost. And for this to be like fully recursive, we need to include that here as well. So paths back. Um, Pass back. This needs to be visiting. And the cost. I guess we could just do the new min cost of S. Or the min cost of visiting. Goes out to pass back. Our new state. And then the min cost of S. Sure. And then now this thing includes a cost. Oh, this should be, I guess, tupled with n cos. So we map that to state, not just a state. We want state and n cost. Okay. If that fixes compile errors, no, not quite. I already had to draw. If CSAT, we don't care about drawing right now. So we can comment that out. And any other issues? On AR on day 14 part 2, uh I've been told that it doesn't do well on that problem. And I think 10x programmer tried it. Can you tell us about that? Yeah. Might want I'll take a look at that link. So, um wait, we still have some issues here. Found state required statement somewhere. Pass back, yeah, okay, state to um cost of S. Okay. Okay. 431. 431 off by 10. Oh, you know what? I could have just deleted the seats from the bad path if that's the case. Nope. Okay, let's. Okay, I'm gonna get the. I've got the answer right now. Let's just get the answer. I suspect that this is the issue, right? The path that's longer. Um, so we're going forward. 1, 2, 3, 4, 5, 6, 7, 8. Right? They both have 8 turns. But now, how many movements are there? So there's 1, 2. Count this with a pen. I mean, you could do like you could train one of your own LLMs. I don't know how well those LLMs do though with writing code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh wait, we can do this faster. So Manhattan. Well, we know 441 was too high. Let's just count these using. I'm gonna count those using like the REPL. Uh, just printing it, didn't I? Let's print what this new thing does. After we fix the bug area that draw required a state. So let's say seats dot map. Wait, seats is a list of states? Oh, hold up. I see what we did here. Okay. This should be a set of points. And we added the end cost. This is now, we'll just make it more explicit. We have a state and we have an end cost, right? And we want to stop pause. Oops. There we go. I don't think we need this case. There we go. Found a mutable set of points. Wait, how are we getting nasty? Nasty. Let's do a T set there at the end. On set of point, we required a mutable set of points. Oh, right, because of this. That's why. 428. That's wait. Our answer changed? Oh yes, because we went to from counting states to counting seats. 428. Let's look at the output real quick. We don't want to give ourselves I don't know, a little time limit penalty. So 1, 2, 3. Hey, it looks the same. I think just our counting of the paths was wrong. I have 2 seconds left to wait. There it is. There it is. Okay, got it, got it. How'd I do? This is a big delta again. I need to oh, I guess a lot of people struggled with part two. I don't feel like I should have struggled that much with part two. And honestly, yeesh, my part one. Well, so part one, I think I had the answer earlier on. I just didn't see that I had it because I just thought it was failing to run. So I went to trying to optimize it. I'll have to scan my footage. Okay, so I'm gonna check the leaderboard. I'm gonna do a quick refactor of this because I think it's pretty straightforward what needs to be cleaned up. Okay, so I'm still holding 8th here. And what happened today? Day 16. I got 16th and 12th. Slowly letting people catch up on me. But geez, Akari in 2 minutes. Okay, Dijkstra is ready to go. This feels more like a real time. 20 minutes to reach the end. Arrow bounce gun 30. Hey, T Blue is here. I think Blue finished T Bow. Is this Blue 19? If so, he finished on the way to work. All right. If I'm gonna be slow at my solution, I'm at least gonna get a nicer looking solution than this. This end reach was for debugging. We don't need that. Let's get rid of the debugging stuff. Seats, that could be nicer. We don't need this anymore. Don't need to import the set. A priority queue and a map is plenty. And reach. Okay. So visiting end cost, once end cost is, so at some point end cost gets lowered. So end cost is still at max value. I'd like to, I think it sounds better that way. If it's still at max value and you've hit the end position, then you set the value of end cost. All right. So we have our states. This is state delta. Um, so our filter, we proceed if min cost for that next thing is empty. Um, min cost, so it doesn't contain it. Not min cost that contains state. Or we do that. I kind of like that better. So there's no min cost. Uh, there's no min cost. Otherwise, we check that's less than the state. Um, so we reset the min cost here. We can actually, I actually feel like doing this with a for all. Well, no, I don't. I don't like what this monstrosity here has become. So in our paths back, we do end up doing with all this tupling. I guess I do kind of have to live with it for now. I guess I'm happy enough with this. I can make it more concise, but that's less straightforward on my current energy level. Nobody used an LLM for part one this time? Really, I think an LLM would get part one pretty fast, no? Maybe they've upped. I mean, if you basically just have Dijkstra plugged in and ready to go. I mean, part one, the only thing you have to do for part one that's different from normal Dijkstra is adding this cost right here. Right? Everything else, I don't know, like all of this is the normal stuff I write for Dijkstra, for the most part. There's no like paths back or whatever. But this is probably verbatim something else I've written before. And you really just have to add like that extra cost when you're getting your next states. So I believe this is probably one where you could compete with an LLM by uncommenting your Dijkstra code and then adding in a cost function. And if you can implement that cost function in 43 seconds, you're golden. Okay, I'm happy enough with this. I hope you all find that readable. I'm always, um, well, I'm always happy to accept critique. If you can't understand something, let me know. I can always rewrite it in a way that's easier to understand. That makes it more fun to watch if it's understandable. So let's find someone to raid. Who's on? Michael PC Gamer is still on. You're in my stream while working on this, huh? Um, well, good luck. I think we're gonna give you a raid. Oh no. Hold on, my monitor just detached. It's been doing that lately. I don't know why. Uh, um, where is Jan? Oh wait, hold on. Where is Jan? Who are you? Fellow Optum engineer. Did you quit Optum? I want to know what's happening at Optum right now. For those of you who don't know, Okay, we're not gonna start the raid yet. I used to work for Optum. Optum is a subsidiary of United Healthcare, and in fact, we had a leaderboard. Let me pull that up just for good old time's sake. Where is Jan? Are you on this leaderboard? Hold on, hold on. I've suddenly lost all my windows. Here we are. Okay, private uh, leaderboard. This was the very first leaderboard at, well, no, nope. I'm not on an Optum leaderboard, am I? Do you recognize any of these leaderboards? Well, surely one of these names is Optum. When was I there? 2022. Is this it? Okay, well, where is Jan? Feel free to whisper me. And